So we're going to start up our second session here. I'm here with Christian Frey live from Switzerland, who is the head of innovation and engineering patents at Siemens. He has been with Siemens for about 25 years, looking after innovation, working across their business units, working with their engineering teams to patent their systems, and now he has a focus on digital engineering. So I'm not sure if I think there's a video that we're going to play that kind of introduces Christian, and then he's going to jump back on. So I'm going to sign off, and we're going to play this this introduction video that will introduce enabling ecosystems.
Siemens, ingenuity for life.
Hello and welcome to my session of the Digital Building Twin Ecosystem, which is enabling smart buildings for innovative applications and services. My name is Christian Frey and I work for Siemens Smart Infrastructure at the headquarters based in Zug, Switzerland. A digital building twin brings together machine-readable, dynamic and static data from multiple sources in one model and enables herewith informed and effective decisions to be made. With digital twins, as designed and as built models will be synchronized, thus allowing companies to continuously monitor the real progress against the initial BIM-based planning. In my presentation, I'm going to explain the challenges and how a digital building twin is turning them into strategic opportunities. On average, employees lose 1 to 2 hours a week due to issues like finding a free workplace, adapting the environment to their needs, and many more. This costing our economy billions a year. Now the question is your building holding you back? Despite that, building and workplace experience isn't always thought of as a strategic priority in our sector. But what is changing is the way we all work. Across all sectors, flexible employment is growing and there are more external workers than ever temporarily supporting teams with their specific expertise. Next to this, technology has also revolutionized the way we work several times already in the last 30 years. And the fourth industrial revolution, and maybe also the effect of the coronavirus, is already driving the next huge shift. Now the question is, what makes a good workplace experience? How can we, the building and construction industry, ensure that we designing, constructing, and maintaining buildings and offices that work? Designing and managing great offices isn't anymore just about creating and maintaining a space that looks nice in photos or in 3D renderings, the catchwork Hollywood BIM. No, it's about understanding and the different spaces and assets people need to be productive. Delivering a genuine, active-based workplace is the key to producing better ways of working. Whether you're designing, building, procuring, or maintaining commercial workplaces, it is vital that we get recognized and the important role smart buildings play in our economy in delivering productivity. This is highly important, especially these days, as we all know, in hospitals and in the whole healthcare environment. Now, the question is how to stay ahead in your market and become more efficient. And how can smart buildings help you to grow your business faster than competition at lower cost and less risk? Well, digitalization will or does already impact all stakeholders throughout the entire process, from the design and the engineering phase to the construction phase and to building operations. Our customers want their data to become more visible and to get the heartbeat of their building on a dashboard. With computer readable data and the digital building twin, we can use IT technology instead of people to do the analyzing of the building performance so that decisions can be based on facts and numbers instead of assumptions and opinions. Based on adequate building data, we expect better decision making and improved service processes and to deliver a great customer experience. Furthermore, our customers take the advantage to cut costs, improve quality and transparency, and to build value to the market. For example, interpositioning is a topic that has attracted a lot of attention in the past 2 decades. This is mainly due to the success of auto-positioning systems, typically with GPS, and the provided services based on this technology. The goal of interlocation services is to provide similar services as they can be found based on auto-location systems at places where satellite signals cannot be received. Among components, the service segment in the interlocation market is expected to grow at the highest growth rate during the forecast period. But fundamentals to run all these services is a digital twin of the location, like in buildings such as airports and malls or hospitals and offices. And many of our customers expect new digital services. Therefore, a digital building twin will have a huge impact on new business models in our industry. As a traditional player in the market, we need to adapt before new players will create digital offerings and change the rules of the game. Now, as I mentioned before, GPS and the provided services based on this technology enables new business. And you all know Google Maps and Google Earth, and you also may use it regularly day by day. Well, the Google Maps is a web mapping service developed by Google. It offers satellite imagery, aerial photography, street maps, 360-degree interactive panoramic views of streets, real-time traffic conditions, route planning for traveling by foot, car, bicycle, and air, even by public transportation. What you see here is the location of the Siemens corporate headquarters in Munich, with attached information on how to get there from your current position and how to get in touch with the company via phone and many more information. And if you will take the subway, you will even get the train schedule displayed. Isn't this convenient? In March 2011, indoor maps were added to Google Maps, giving users the ability to navigate themselves within buildings such as airports, museums, shopping malls, and other public places, including underground facilities. To get this data, Google encouraged owners of the public facilities to submit floor plans of their buildings in order to add them to their services for their users. Their cloud-based ecosystem consists of 3 main pillars: the spatial information, the assets and their location, and real-time information, as you can see here. Now, the question is, how can we transfer this approach to the building industry? The 2D, 3D construction plan is what we all know. This is our static digital construction twin. It contains floor plans and views of the location. Enhancing this plan with a digital product twin of installed equipment gives you further information on your assets. Now, if we combine those two twins, we get a third one with location-based information and real-time data. It gives you many insights on your building KPIs, supporting better decision-making and optimization of operations 24/7. Now let's assume you have a 3D map or an image of your location. You click on a position of interest, and here is what you get. You're now virtually on site. An indoor scan shows you the environment, and installed building equipment is delivering real feedback with the current value measured besides historical data. And as you can see here, I have selected this air quality sensor, and this is the actual data and the history of all the data. By the way, we also can use this as for occupancy detection of the meeting room. Now, what are technologies shaping these new trends? Firstly, we get data from the systems installed in the building. Next, machine learning and artificial intelligence helps to understand and correctly interpret this data. Furthermore, IoT is on the rise and will change the access to sensor and actuator technology in buildings. And to be able to access and influence a system at any time and from anywhere, we are now cloud-based, enabling us to bring our applications to market quickly and scalable. And in order to map buildings using a consistent digital building model over their entire life cycle, with all their relevant information, a method is needed to ensure this, namely BIM. In the life cycle of a building, many stakeholders with different challenges are involved. An owner or investor needs transparency of actual building structure and rented out space across the building life cycle to help him to drive his strategy. This is supported by one single source of truth for multiple life cycle applications and easy access to all building data. A planner or consultant needs unified access to data for an efficient planning to eliminate risk during the construction and operation phase. For a general contractor and a project manager, it will enable a hassle-free execution of their work in time and in budget. Building operators or facility managers want to be able to control the different systems from anywhere while optimizing processes at the same time. Therefore, accurate and up-to-date information on the building and its assets need to be accessible in real time. This presumes an open, interoperable system that allows seamless sharing of data and a scalable ecosystem which allows to deliver services in the most cost-efficient way. Corporations and tenants may have too many spaces that are unused by their employees, and they have their favorite places day by day. In order to identify less attractive spaces and reuse or renovate them, you need insights of your building in form of reliable, machine-readable data. This will help to find the best balance between employee satisfaction and cost efficiency. With the digital building twin, we overcome those challenges and turn them into strategic opportunities. Okay, now you all know about BIM and you heard about the digital building twin. The question is, how do they get together? And which one do I need for my business? Well, the answer is both need to coexist. And here you can read why. BIM is a process supported by various tools, technologies, and contracts involving the generation and management of digital representation of physical and functional characteristics of spaces. And the digital building twin enables user-centric services that generate high business values. Hence, we conclude that BIM and the building twin are not a contradiction, but a synthesis. And here you can see the growth of common data along the life cycle of a building. It's about gathering data from the planned and installed products to the as-built digital building twin to make operation and maintenance of a building, including its assets and tenants, more efficient. Now, what are the challenges in transferring generated data? Over the life cycle of a building, from design via construction to operation, a lot of data is generated and needed. To date, the transfer of construction data after the individual phases is often associated with a considerable loss. We heard before in the presentation that this is still transferred by paper, so it can't be this way. So this is getting better with BIM, mainly during the planning and construction phase. However, a building twin-based project shows much higher performance with high value transfer in the beginning of the operation phase. This has a very high impact on the life cycle cost of a building, since the operation phase contributes 80% to it. Now, how do we at Siemens Smart Infrastructure look at the digital building twin ecosystem? Mainly by driving business value throughout the building life cycle. Benefits and added values are static building data as basis for the building structure, like floor plans, number and size of windows or doors, or the dimension of the electric panel. And building data, mainly engineering data like BACnet data points and functions, or functional data like which control program is running in the controller, or data of installed equipment like the serial number of the chiller in the basement. And dynamic data, mainly status information like room temperature or operating hours of a fan or water consumption during the day. Occupancy information like number of persons in space or the percentage of time occupied. Location information to find person or nearest equipment. And external data like weather forecast, electricity rate, and so on. However, machine-readable data, which with a rich and consistent data semantics, must be available from a unique single source. Now, during the design and construction phase, BIM greatly improves collaboration between involved stakeholders and significantly cuts costs. With BIM, typically fewer change requests are made due to more time spent in the upfront planning. Therefore, the use of BIM is a differentiator in the market for general contractors. However, increasing building complexity and higher tenant expectations raise the pressure on facility managers and operators. A digital building twin provides the transparency to continuously optimize building performance throughout its life cycle. The digital building twin makes it possible to operate buildings based on greater insights. The use of data analytics and simulation enables better operational quality. This will improve the maintenance process, but requires that facility managers know how to use BIM platforms to also maintain the digital building twin. To enable companies to run their business according to changing needs, tenants demand a high degree of flexibility from the facilities. They also depend on a suitable environment for the productivity of the employees and satisfaction of building occupants. In response, they demand a future-proof building that facilitates their daily business with the necessary flexibility to adapt to their current desires. To make the right decisions, owners and investors depend on full transparency of their buildings, today and in future. These insights enable the highest possible return on investment while minimizing risks. The building twin delivers this transparency, which has been sought after for a long time. Architects and planners and consultants are dealing with steadily increasing risk and complexity. They need the BIM process to effectively plan and execute their projects. The increased coordination during the BIM process gives all stakeholders, including architects and planners, access to the desired data at the right time. As explained, the digital building twin application allows a connected digital representation of a physical building in operation. It brings together dynamic and static data from multiple sources in one building model and enables informed and effective decisions to be made. It bridges the physical and digital world through sensors that collect real-time data within the physical environment. Based on this, it provides real-time understanding of how a building is performing, enabling immediate adjustments to optimize efficiency in operation. The result is a more cost-effective, straightforward, and sustainable smart building. Now, to fully understand the building during operation, it requires a connected, full-featured virtual model with actual operational data from the physical building. The virtual model is our digital building twin. As a prerequisite, it is important that all data needed has a consistent semantic and machine readable. I always repeat this because this is really the key. Siemens Smart Infrastructure provides a suite of tools to enable a building twin to deliver accurate, insightful, and reliable results that can have a real impact on operation, like optimizing performance, decreasing downtime, and extending the life cycle. The digital building twin and its ecosystem supports better decision making, learning, and autonomy. Now, what does this mean for buildings in action? On this slide, you find the main functions and services listed that are based on a digital building twin and its comprised data. A single source of truth and machine-readable data based on common semantic makes the difference. In the following, I briefly show in an animation how specific data models merge and generate the BIM as-built model. After the planning and construction phase, the combined unique digital model, also known as construction twin, is the basis for the building twin for operation to maintain performance of the building. This building twin is based on the static building data enriched with real-time data during operation and adjusted to changes until end of life of the building. Now, this use case shows space optimization supported by occupancy detection. It helps to identify hotspots and unused spaces. This information assists to optimize the overall building performance and the efficiency of its occupants, normally your highest cost in an office space over the lifetime. The same here. Finding a colleague or your team or just a free meeting room or the nearest printer makes your time more efficient and reduces stress. To book a meeting room and to inform your team about it, increase the overall performance of your project. Preferred personal parameters are automatically preset to the meeting room assets based on your input or via machine learning of your preferences. Now I need to see my camera. Tom, short question, how do I switch on my camera?
Yeah, there's on the top.
There is a button in the top right corner.
Okay.
It looks it's next to the microphone one. It looks like a camera. You got to click on that.
That's missing on my screen. Can you switch it on for me?
Honestly, I don't think we can because it's a security thing on your end. You have to enable it.
Oh, okay.
On my screen, it's the third top on the top bar. It's the third icon in from the left.
Yeah. It was there before. It has gone. Anyway, so yeah, and finally, you tell your environment about your preferences and current condition. But instead of setting an absolute temperature value on a wall thermostat, you just tell the system whether you feel too cold, too warm, or just okay, in case you feel comfy. Based on the common feedback, which includes all the occupants around you and in the same space, an average value is set by the system and communicated back to you. And if you are the only one feeling too warm, just take your jacket off. And with the Comfy app on the phone, I hope you can see it now. With our Comfy app, you also don't need to touch a room control unit, which furthermore limits the spreading of a virus. And what I will do now, I will show you the Comfy web application. Hope you can see this.
Yeah, we can see it.
Okay, very good. So this is our headquarters based here in Zug, Switzerland. And you see this app gives you a lot of information. Of course, the top priority at the moment is COVID-19 update. Then you have the room, the building actions, which we come to this later. You have many more information. You can see the lunch menu that is available. You have a train schedule. You have information about our fitness room. You have parking information, and you even can call a taxi. So now, if you want to change the room temperature in your room, you just click here, and this is what you get. So you have all the information about the room, and you can now say, hey, I'm comfy. And then the system gets this information, and the temperature is just okay for you. So, and if you want to, for example, book a meeting room, just click here. Then you get all the meeting rooms, and you see their availability. Or let's say you want to find the nearest printer, as we said before. You just go to the map, check where the printer is, found it here. And then you get the navigation and all the information that you need. And if the printer is broken, you can even set a work request. So this is really convenient. Okay, so you have also in your handout, you have this information about Comfy, or you go to comfyapp.com, then you get a free demo from our Comfy team. Now, going back to the presentation. Okay, as you all know, digitalization has a potential to transform whole industries. The building and civil engineering industry and construction industry are no exception. However, changes in the construction industry can only be achieved through the openness of practitioners to emerging technologies. The appearance of new technologies is a decisive factor that will contribute to mastering current and future challenges. With this, I'd like to close my presentation and be open for questions. Thank you very much for your attention and stay healthy.
So I don't know if there's a way to sort out your camera, but that's okay. We got your audio. That's probably good enough. Everyone can just imagine that you're a very handsome guy with a full head of hair. Anyway, so there were a couple questions that came through here, and we do have a few minutes. So I'm just going to go to the questions area. Okay, so at present, the implementation of BIM is highly fragmented across the building value chain. How does Siemens help customers to overcome this challenge to ensure seamless flow of data across the value chain?
Yeah, for this reason, we are also a partner from Building Smart International, because we count on IFC, which is the common, let's say, semantic for the data in construction. Instead of having closed information, we want to have open information, and then we can read this from multiple sources, and then we have what we need.
So most of your products utilize open standards like IFC for the model viewer, for example?
Yeah, the IFC is the basis. I mean, at the moment, it's mainly supporting the design and construction phase, but we work with Building Smart International in order to get all the information that we also need from via in the IFC standard for the operation phase. So for the building equipment, as I mentioned, BACnet and KNX and all the other standards are supported by our controllers. And then we can read, let's say, temperature values and stuff like that, even if it's an existing system from a third party.
Can you just quickly explain BACnet, which is a standard for BSA or building automation systems, correct? Language?
Yeah, the BACnet has nothing to do with Building Smart International. The Building Smart is about the construction part, and the BACnet is the protocol that runs on the building automation system. And with this, we are able to share data between different systems on a common language.
Okay, so you're able to integrate those two systems together. So a new question here: how will the system adapt to any additional or alterations during operations phase of the building?
Yeah, as I said, I mean, most of the buildings that are existing, and most of them have no digital building twin.
Right.
So the real challenge is really, how do we get buildings digitized? There's a company called Navis. They do this indoor scanning and so on. So how do we get from a scan the IFC of the building? This is the main challenge at the moment. But a lot of companies are working on that. I also was just participating in a EU H2020 call as to look after the proposals from the different universities, and exactly this problem was described. And the EU is sponsoring this because also they see also the challenge that we need to digitize the world around us. And as I mentioned, what Google did with our Earth, we need to do within the buildings.
Yes, it's super challenging. And then the culture of all this information, like getting the culture, the people aligned so that all the siloed information comes together and can be utilized long-term, has got to be a big challenge as well. Mm-hmm. Is there any thought around, I mean, you have a lot of the controls data and you have a lot of performance data around equipment. Are you collecting that data or thinking to collect that data So you can start to do predictive analysis, like failure analysis, to understand what the fail point is on certain equipment by sort of correlating all your customers' data into a common pool and then analyzing it.
Oh yeah, we can analyze the data. I mean, we can also analyze the whole building. We have a system called Smart Building Recorder, where we also analyze the building over time to see whether, for example, whether the right thermostat is controlling the right heater, because this can be very often mixed up. Or another example I have in our building in Munich, in the headquarters, we found out that the air conditioning is running for 1 hour during the night, and we didn't know why. So we analyzed the data, and we found out that the safety guard was running around. He was checking all the meeting rooms, and with a presence detector, the light was switched on, and in addition, the air conditioner was switched on, and it was a minimum run for 1 hour. So we analyzed this, and then we reprogrammed the occupancy detector to be triggered within one minute several times before the air conditioner switched on. So all these things can be found with the data analytics, and they save us a lot of money in energy, and also it's better for our environment.
Yeah, excellent. Probably hundreds of thousands of dollars saved times hundreds of thousands of buildings.
Yeah, right. Just think about that. Another issue we had was, for example, we analyzed that we saw that water consumption was also not that high as during the week, but also over the weekend there was a higher water consumption than normal. And then we tried to find out what is the reason for that. So we analyzed this and saw that one of the flush button of the toilet was hanging, and the water was running the whole day. And again, here the data gave us the hint that there's something wrong. So if we don't have this digital representation with the analysis running on it, then we won't find all these issues.